Welcome. Thank you guys all so much for coming. We had two phenomenal first speakers, so I'm excited to be third. We'll see how that goes. I am the director of data science at a company called Scarfos. We are a startup in Charlottesville, Virginia. I'm going to tell you a little bit about what our company does throughout this talk, but mainly I'm here to tell you about how to include machine learning in your iOS apps, right? What are both some strategic and some practical considerations for actually doing this? So I'm not an iOS engineer, I'm not an iOS developer. I come from the world of data science. And so I'm excited to learn more from you guys as the day goes on about Swift and writing all these cool apps, and I'm here to talk about the machine learning side of things. Okay, so this is what I'm gonna cover in my talk. First of all, why should we even do this? Why should we think about including machine learning in our mobile apps? Sometimes we don't need to, so why should we do this? I'm going to give you a demo of our app, the Boot Finder. You can see I brought some props here. And if you would also like to download this app, you can scan this QR code and download it for free from the iOS App Store. So I would love it if you guys would do that with me. Then I'm going to talk about some architectural and technical considerations. How do you actually get the machine learning models into your app? And then finally, at the end, we'll hopefully have some time for Q&A, but if not, I will be here through lunch, and I would love to talk to you. So why machine learning? Well, mobile has evolved. You know, the App Store came out in 2008, I think it was, and mobile has evolved a lot since then, and I think we all expect our apps to be smarter. If I ask Siri something on my phone, I expect her to usually give me the right answer. I expect my apps to know things that maybe I didn't have the same expectation of 5 to 10 years ago. And a lot of that is possible through machine learning. So that's thing number one. Thing number two is more personal, less creepy. And where this line is has really evolved. So I don't know about you guys, but 10 years ago when Amazon would give me a recommendation for something, I'd be like, oh, that's a little weird. How do they know me? And now I just take it for granted, right? If I've been shopping for boots and then suddenly all of the ads on my websites are for boots, I don't even think about it anymore. So the line is evolving. But I think that one thing we need to think about when we're building apps and thinking about user experience and thinking about data is we want our apps to feel really personal and really unique to us, but not be creepy. So you guys probably are all familiar with the Face app, right? You know, you take a picture and it makes you look 50 years older, but then everyone's freaking out because we're sending our photos to Russia, right? So there's not a lot of easy answers to these privacy questions, but it's something that we need to think about, and it's something that we need to think about for the data that's powering these machine learning models and for making our apps more personal, less creepy. And then finally, when you include machine learning, when you include AR, I think we're gonna have a talk about this next, you can do things with your app that were just not possible otherwise. So here's an example of an app from Wayfair. So I recently bought a house, and I need to get a bench for my entryway, right? So my kids, when they come home from school, they can put their shoes in the little shoe cubbies and put their backpacks on the bench as opposed to all over the living room floor. And so Wayfair has this app where I can actually find a bench that I want, and then I can use a view in room feature, and I can get a better sense of what this is actually going to look like in my house. So not only is it a better user experience for me, but Wayfair has found that with this, people are 3.4 times more likely to purchase. So it's a better user experience for me because I can do something cool with machine learning or with AR that I couldn't do before. And then for the business side of things, it's gonna increase the likelihood that people might actually buy products from you. Okay, so I'm gonna walk us through a couple of examples, and then I'm gonna give us a demo of the Boot Finder. I'm also gonna do what you're not supposed to do in talks. I'm gonna go back and forth from my slides to my phone to Xcode, so we'll see how all of this works out. I think Daniel did it the smarter way with all the including the code in his slides. Okay, so our director of product, who is awesome, came to us from Starbucks, where he had the opportunity to work on the Starbucks mobile app. How many of you have used this app? Yeah, a fair number of you, right? You order your drink, and then you go to Starbucks and you pick it up. So one thing that Starbucks was trying to do was give people, they wanted to increase revenue per ticket, right? So when you go in and you purchase your latte, it might recommend for you a food item that you'd want to pair with that latte, since, you know, I think until recently, most people thought of Starbucks as a coffee company, and they wanted to, you know, increase the likelihood that people would also associate them with food. Hey, I can get a whole breakfast. So what they decided to do was put a recommendation engine into their app, right? So I order, based on my data, based on, the wisdom of the crowd, I order my latte and it recommends some sous vide egg bites. And I'm like, hey, that seems really great. I would like to have those. So I have a better experience. I get a good breakfast, and Starbucks is happy because I spent more money. And I want to highlight two things about this app that I think are good paradigms for thinking about some of the challenges with getting machine learning into apps in general. So the first is lack of artificial intelligence or machine learning experience. So have any of you here tried to build a machine learning model? Okay, yeah, that's good, that's awesome. How many of you have worked with maybe a data scientist on your team or within your organization to try to work together to do that? Okay, so some of you, even less of you, interesting, okay. So this is a common challenge that a lot of businesses face, is just not having the in-house expertise for how to do this. It can be challenging, right? And so what Starbucks did was they engaged with experienced people, they hired an external firm, and they were able to do this successfully. And then number two is scoping a meaningful approach. And I'm going to talk more about that throughout this talk. There's a lot of excitement around machine learning. People want to, I want to have deep learning. I want to do this cool thing. I want to use a generative adversarial network. I'm saying all these words. What do they even mean? The point is, when you're thinking about this, simple is often better. Like, it might not be the coolest, most cutting edge model. Recommendation engines are well understood, but it really provided a benefit to both Starbucks and their customers. And so this is one recommendation I often give people, is start simple. Don't try to boil the ocean. You can always add in complexity later. And I think that this quote from Jerry, the Starbucks CTO, is really important because the tech needs to enhance the experience, not get in the way of that. I think that's true with technology in general. I think it's particularly true with machine learning. Okay, so now the boot finder. I'm going to talk a lot about boots in this talk, and I want to thank Jamie for wearing those awesome boots at her talk. I love them, and she let me take a picture of them, and that was very gracious. So the boot finder is an app that we built. It's the one that you can download using that QR code. And so the goal of this app, again, very simple, allow customers to take a picture of a pair of boots, and then using a machine learning model, it identifies boots similar to the one that I just took a picture of, right? So I don't need to go to the Zappos website. We're using Zappos data to do this. I don't need to go to the Zappos website and type, I want a black boot with a 2-inch heel and all these things. I just take a picture, and it matches me with the most similar ones on the website. And if I'm interested in purchasing them, I can click a link to purchase. That's it. But this is an example of machine learning in an app that could potentially create a new customer acquisition channel. And I think it's a new way to experience the app or to experience purchasing boots. I was talking a few slides ago about Wayfair and how that technology was not possible without machine learning. Well, in that case, AR. But this case, being able to take a picture and have it match, that's machine learning, and that's a cool new experience. So now I'm going to demo it, and then we're going to talk about how to build it. Okay. So here's my kids who like to throw their things on the floor. I'm going to go to the Boot Finder app. Good, you can see it. I also have this problem when I do these demos, is I put the iPhone screen behind my slides. So I'm like, and there you can see it, and everyone's like, we can't see anything. Okay, so here's the Boot Finder app. So we're going to find some boots. So I'm going to take a picture. And it gave me some boots, right? They're not identical. I didn't happen to get these particular boots on Zappos, but you can see, short boots, not a high heel, various colors, and that's it. And if I want to, I'm going through, I kind of want these boots. And it takes me a link to Zappos, and I can buy them if I want to, not buy them. So that's it. You can download this. You can do it yourself if you want to. Okay. So that's the app. So now we're going to talk about how to build it. Okay. All right. And so this actually, I want to thank Jamie again, because she and her talk teed me up pretty nicely, actually. So the question here is, how do we construct a useful app? And one thing she talked about was starting with the why. Why are we doing this? What is the point of this? And when it comes to putting machine learning into your app, do I need to do it? For a lot of cases, yes, this can make your experience a lot better. Sometimes maybe you don't need it, and that's okay. But you want to start with the why. Why am I doing this? What is the business use case? So in addition to that, we're going to talk about that. That's the first thing you need, is a goal, is a why am I doing this? What is the problem I want to solve? How can I make my experience better for my users? And how can machine learning help enhance that? Number two is the thing you guys all know far better than I do, which is writing the iOS app, which we're going to look at some Swift code. I'm going to show you some pieces of our app code. Number three is a machine learning model. And then number four is a way to tie it all together. Since the process of building a machine learning model is not the same as the process of building an app, and that's okay, but you need a way to glue these two pieces together, and that's where our platform comes in. Are there other ways to do this? 100%, yes there are. MLKit is one of them. Am I biased and think ours is the simplest and best way? Yes, of course. So let's get that out of the way right now. But we're going to talk about why it's important to tie these things together. Okay. So in this particular case, we're going to also, as you guys have probably surmised because you're pretty smart, we're going to use the boot finder as our guidepost throughout this talk, so we have a concrete example. But as I'm talking about this, I hope you're thinking in the back of your mind like, hey, I'm building an app and it might benefit from machine learning. Or hey, I can see how this would apply to another use case. So we're using the boot finder to anchor us, but this is one example, and we hope you guys will come up with many, many more. So the boot finder is an example of an e-commerce app. And if you're building an e-commerce app, you might have two goals. One is you want to create a new customer acquisition channel. And two is you want to create a personalized shopping experience. But again, you don't want it to be creepy. So what are some things that I might want to keep in mind? And these were some things that we kept in mind when we were building the boot finder. So number one is I want to drive users to my inventory quickly. I want to quickly enable them to get to my inventory. I don't want to send them to DSW. I don't want to send them to Nordstrom's. I don't want to send them to 9 West. I want to send them to Zappos. Number two, most retailers are updating their inventory pretty frequently, right? We're getting into August, back to school season, boot season is in the fall. Zappos is updating their inventory. And so we need the machine learning model on our app to reflect that. So that's another thing we need to keep in mind. And then, of course, again, user privacy. There's a number of different ways to architect these systems. And as I said, it's not a completely solved problem. There's a lot of things to consider. But one of the ways that we're doing this is keeping the model on the phone. So when I took that picture of the boots, it stayed on my phone. It doesn't go to Scarfos. It doesn't go to Zappos. It doesn't go to Amazon. It stays on my phone. So that's one thing to consider, again, as you're building these things. And I think for those of you who are at DevDev, heard the theme of privacy over and over again in those keynotes. Okay, so now before I get into the technical weeds, I want to talk about what I call the functional architecture for the user experience. And the reason I'm doing this is because there is often a lot of confusion when you're building machine learning models for the first time between the process of training or building the model and the process of actually using it, and those are two different things. And so I want to call this out as the architecture for the user experience, because this is how the user is going to experience the machine learning within the app. So this is basically exactly what I just showed you guys. I identified a pair of boots I like. I take a picture of it. These are actually my rain boots. It was raining a couple weeks ago in Charlottesville when I was working on this talk. And so I took a picture of my rain boots. Boot Finder presented me with some choices, which are not hugely similar, which doesn't surprise me because I bought these boots a long time ago in Toronto on the clearance rack, and they probably don't make them anymore. And so I have the choice to buy or not buy boots, and I'm choosing not to buy. They're still in good condition. But that's what the user's doing, right? They take a picture, they get a list of boots they want, they buy or not buy, that's it. So that's how the user experiences the app and experiences the machine learning. Okay. So now I want to talk about a solution, how you would typically do this, and what prompted us to start thinking about this problem and building our platform, Scarfos, to help solve it. So there's two. I have the bottom row, which is the process of training the machine learning model, and I'll talk about that in more detail in a few slides. And then the top row is building the actual app. So you're in Xcode, you're in Swift, you're doing all the things you do. Then you need to drag the model in to your app, right? Is one of the resources. You need to bundle it all together. You test it in test flight. You submit to the App Store. It's approved after X amount of hours. And then away you go. Well, what about when you need to update the model, right? If this is the process you take, which is okay, this process might make sense for you, every single time you update that model, you're going to need to resubmit your app to the App Store. And for example, Zappos updates their inventory every single day. So if you're not making any changes to your app other than the model, you probably don't want to have to resubmit it to the App Store every single day to make sure the inventory is updated. The other thing, which I've mentioned a little while ago, is that these two processes happen on different cycles, right? The process of building a machine learning model and training it and validating it is usually done by different people and on a different time scale than the app developers. And so you guys don't want to block each other, right? You want the machine learning engineers or the data scientists to be able to build their model, and you want you guys to be able to build your apps, and you don't want to block each other, right? So you need a way to sync these two processes. So that is part of the reason we built Scarfos, right, is to make this process easier. So using our Swift library and using our Python SDK in our platform, you can push new models to your app without having to go through an App Store update. And it makes the whole process a lot smoother. And I'll also say, I'll be totally transparent, I'm glazing over a lot of the details of all of these things because I only have 45 minutes to talk to you. But if you have more questions about all of the technical details of this, I'm here all day, as is Wes Cope, who's sitting right in the front row. He's our director of architecture and leads our iOS team, so he can answer questions as well. All right, so let's talk about machine learning. Okay, so here is the process for how we built the model that is in the Boot Finder app. And before I start, I want to draw your attention to this GitHub repo that is listed at the bottom. So in addition to putting the app in the App Store, we've open sourced the code that we use to build the model and the code that we've used to build the app itself. And I'll have that in a few slides as well. And part of the reason for doing this is a lot of people have talked to us about, you know, I have challenges figuring out the right problem, but then once I figure out the right problem to solve, I don't know how to do it. I don't know where to start. And so we open sourced all of these to hope that you guys, the people you work with, would be able to look at it and use it as a template for machine learning. So we would love it. Go fork the repos, clone them, ask us questions. That would be awesome. Okay, so how does this work? Well, the first thing that we do is we go to Zappos.com and we pull off all the images of the ladies' boots. We started with ladies' boots. We could have included more, but we wanted to start there. Again, it was like Jamie was talking about, you need a proof of concept to start with. So we put all of those boot images in an Amazon S3 bucket. Have any of you guys stored stuff in an Amazon S3 bucket? Yeah, some of you. If you haven't done it, super easy. We also create a JSON file. So you probably recall when I was using the app, it didn't just give me pictures of boots. It said, here's the name of the boot, here's the brand, here's the price, and here's the link to buy it. So that metadata we also pulled off the website as well. We then used a Python script, which I will show you in a minute, using a library called Turi Create to actually build the model. I don't know if any of you are familiar with Turi Create. They were purchased by Apple about, let's say, 2.5 years ago for $200 million. So Apple is really committed to machine learning and building out its machine learning capabilities. The great thing about Turi Create is it abstracts away a lot of the more challenging pieces of the model build process. So if you haven't done this before and you're feeling intimidated with another library like, say, TensorFlow, which is awesome, but there's a bit more of a learning curve to get started, Turi Create's a great place to start to get your bearings to figure out what's going on. So we use Turi Create. Once we've trained that model with the available data, we convert it to Core ML format, since Core ML it's designed to work in your iOS apps. It plays really, really nicely with Swift. We convert it to Core ML, and then we have this integration point. And the integration point could be Scarfos, it could be something else. But the thing I want to emphasize here is you need a way to get these models into your apps, or into your web app, or into your desktop client, or whatever it is that you're building. You don't want the model to live over here in a sandbox, and it's cool, and you don't do anything with it. You really want to be thinking, when you're thinking about the why am I doing this, and the how am I going to architect it, you really want to be thinking about how am I going to deliver this and actually get it into my app, so it's not just a cool idea, but people are actually using it. So we have the integration point. Okay, and the other thing, I apologize, I don't think you can see it on this slide, is this is cyclical. This has to happen periodically, whether it's daily, whether it's weekly, however often the inventory is being updated, you probably want to retrain your model. So the way we've done this is using Docker and Kubernetes, so it runs automatically, and we don't need to manually run it however frequently. Okay, so let's look at some code. It's going to be Python. Do any of you write in Python? Some of you, yeah. I like Python. It was one of the last languages I learned, but I actually really like it a lot. Okay, we're not going to go into this in any amount of detail. But basically what's happening is exactly what I described on the slide. We're ingesting this new data. We're using this library called Beautiful Soup, where we have to go through all of the HTML on the page, find what we're looking for. Here's our metadata. We do this until we run out of boots. Then we organize it. Then we check to see, do we have new boots? If we don't have any new boots, we don't need to do anything. The existing model is fine. And then we get to the point where we upload this data because we want to save it on S3. We train the model. We convert it to CoreML. We upload it to S3 to save it there, and then we push it to Scarfos. So I'm going to pause for a second. I'm going to say one thing that if any of you have tried building a machine learning model and you were like, I am spending so much time cleaning this data, I can't even get to the model building because all I'm doing is like the data's in the wrong format and everything is breaking and I'm so tired of dealing with this data. If you get to that point, it means you're doing it right. So the worst, like the absolute hardest part about machine learning is getting the data into the right format so you can actually build a model with it. So if you find yourself spending all your time wading through those weeds, you're doing it right. Just keep going. It can be a slog, but you'll get there. Okay, so I want to call your attention to two things. So one is the retrain image similarity model. I'm going to go to this function in a second. And the other is the upload model to Scarfos. So we have built a Python SDK to make this easier for you to take models from wherever you're training them and get them into our platform so you can deliver them to the apps. So there's a lot of different places you can train machine learning models. You can do it on your laptop. You can do it in Google Colab. You can do it on AWS SageMaker. You can use IBM Watson. You can use some hardware that your organization has spun up. There's a lot of different ways to do it. But as I said earlier, once you've done it, you need to put it somewhere. And that's what this does. So I'm going to scroll back up and look at these functions. Then we'll put away this code, and I'll move to Swift. And I won't show you any more Python, I promise. This is when I was talking earlier about Turi Create and how they make it really easy to train models. This is the model training. You load it into a S-frame, you add a row number, and this tc.imagesimilarity.create, that's the model training. That's the building of the machine learning. It's one line of code. All of this other code is wrapping it to make sure we have the right data, it's in the right format, and we can send it someplace. And then finally, the uploading the model to Scarfos. You get an API token from our system, and you just ship it, and it will show up. And I will show you where these models go in a few slides. Are we good? Okay. All right. So now we're going to talk about Swift. And this is where if I say something wrong, Wes is going to tell me. So now we're going to talk about this piece, right? How do you include the Scarfos Swift framework into your Boot Finder app so these model updates will happen? So when you ship the model, your app knows, like, hey, there's a new model available, and I need to receive it. So there's two things you need to do. You need to integrate Scarfos, or if you're using something else like MLKit, you would have to do similar pod installs and import statements. And then you need a class that contains the logic where the class itself actually interacts with the CoreML model. Since that is how, when I take the picture and it gives me a list, I need to pass it into the CoreML model, and it gives me a list of results. And so I took a picture here of my Xcode. And so there's two places where I do this. One is in the app delegate, and one is in the class with the logic. And at the bottom, this is a different GitHub repo. So this is the Boot Finder repo. This is for the actual app itself. And you can download it and build it. And it ships with the default model. So you can see over on the right, underneath resources, we have boots metadata.json and the image similarity ML model. Those are the two components. Those ship with the app. And then when you do model updates, those two things are updated. But those, the first time you do it, you do need to drag those things in and bundle them with the app. And then every subsequent time, the updates happen. All right. So let's get back into some code. All right. OK. So I'm in my app delegate file, and there's two keys. There's a development key and a production key. I will show you where to get those in Scarfos. And the reason we have this is so we know the right model to ship to the right app at the right time. So we are hopeful at Scarfos that we're at the very beginning of this, and that soon people will not have just one machine learning powered app, but 2 and 3 and 4, and they're all going to have different models, and you need to make sure the right thing is delivered to the right app. And so these keys help tie it all together, and we give those to you. The next place is in Boot Finder. So this Scarfos.load function, and we're gonna go back to the app in a little bit so we can see what's happening here. But this is where Scarfos says, hey, is a new model available? If it is, I'm gonna pull it down and I'm gonna use that new model instead of the one that I had previously. So you add this Scarfos.load function. And then in the find boot, so that's the Scarfos piece. And in the find boots piece, there's this calculate similarities. So if I go to the superclass, here is where I'm calling the actual model. So there's this core ML model, and you have the appropriate import statements up at the above. But you actually have this ML model object. And then what it's doing is it's calculating a distance between these boots and all the boots in the model. So it knows which one is the most similar. It's a distance calculation. So that's it. It's just those two things. And you guys all know how to build apps. So this would be really hard for me. I think it would be really, really easy for you guys. OK. So now we're going to talk about the Scarfos piece. So I'm going to show you the platform, and we're actually going to update the model, and we'll see what the app looks like with the new model. So I'm going to go. So this is our Scarfos dashboard. We have a number of different apps. So these are a bunch of different apps that we have in our demo account. And I'm going to go to the Boot Finder app. And in the Boot Finder app, I have an image similarity model, which is the one we've been talking about, and this thing which is called This Is New. This was us doing some testing. We don't need to worry about that because I haven't told my app to expect anything other than image similarity. So doesn't know, doesn't care. You can have as many of these as you want, but unless you've told the Swift code that it needs to care about and do something with the model, doesn't matter. So I'm going to go to image similarity. And these are all my different model versions. But before we talk about that, I want to go to the integration guide. So we work with CocoaPods and Carthage. And remember I told you how we give you the environment keys? Here they are. So right in the integration guide, I literally cut and paste this into my app delegate file. And now Scarfos knows, OK, this is the right model. This is the right app to connect with that app in the App Store. And then it gives you additional information about how to do this. So here's the management part. So we have different environments. There's development and there's production. And you can ship different models to dev and different models to prod. And so right now, we have model version 11 is in prod, and development is all the way back at model version 8. So what I'm going to do is I'm going to deploy a new model to my phone, and we're going to look at it, and we're going to see what the difference is. So I'm going to deploy. I'm going to select prod. OK. Now we're going to go back to my phone. We're going to open the Boot Finder app. And I'm going to tell it, so you can see I have model version 11. And now I'm going to check for updates. And it's telling me a new model is available. And now it's downloading that model. Now, the check for updates button is not something you would need in your app. This happens automatically behind the scenes when you use the Scarfos framework. The reason we have the check for updates button is so it's clear when I'm doing this demo that something is happening. You're welcome to include it, but it's not. I just want to be clear. It's not something you need to do. OK. So now you can see I have model v12 at the bottom. So I'm going to take another picture of these boots. And as you can see, I got different boots. Right? So Zappos has updated their inventory. I now have 5,020 different boots to choose from, and it's ranked them in order. Whereas previously, I only had 4,761. So maybe that extra 350 boots is the thing that's going to make the difference for me. I mean, I don't know. I really love boots, but I don't think I need quite that many. So, but the point is the model was updated, right? We pushed it. It was updated. I didn't go through an App Store update. If you guys download this app, you will now have model version 12 as well. So that's the piece about tying it altogether, right? Where you don't have to, the app development and the model development don't have to interfere with each other, step on each other's toes. And I want to show you one more thing, which is the monitoring. So we have some charts and graphs which show you the number of active devices in the last 30 days that have used your app. And these are not the total installs. This is the number of times the app has been used, the number of devices that day, I think, when it calls down and gets the new model. So on this date, which I believe July 19th, we had 13 people using iOS version 12.3.1 that used this app and pulled down the new model that was available. And why might this be useful? Well, maybe you like charts and graphs, as I do, but it's also useful because you can see who's using your app and what device they're on. How many of you heard the part of the Apple, I think one of the sessions that Deb about Core ML3? So Core ML3 is the new version of Core ML that's going to allow on-device training. However, it doesn't work on all of the iPhones, right? It only goes back, so I think maybe 6S or 7 can use Core ML3. And so it is possible that when you you want to ship different models to different device types. So you can optimize those models for running on different device types, right? If my phone's not going to run Core ML3, but I still want to use machine learning. So these are things we have to think about. We can think about and understand who is using the models in our app. And all of the stuff that gets sent back here, this is just standard stuff in the Apple toolkit. We're not sending back pictures or anything like that. And then we also have the number of installations, right? How many devices have these different versions of the model? And I think that's almost all I have for you guys. So what do we talk about? Why should we do this? Hopefully I convinced you guys that you could maybe think about including machine learning in your apps, or maybe you're thinking about it already. I gave you an example demo so you can see concretely how does this actually work. And then we walk through a little bit of the technical considerations. And I think one of the things that Jamie said, right, we're all tool builders. We build tools like you can do this. Her quote from Daniel, it's hard, but you can do it. I think a lot of people, when they think about machine learning, it's like, it's too hard. I don't want to understand the math behind a neural network. And you don't have to. If you want to, you can, but you don't have to. But you can build these things, right? You can build these apps. And this is the thing that we're excited about at Scarfos. It's not just giving you guys the platform, but it's working together to teach you how to fish. So we can work with you, figure out what is the functional architecture I want? How do I do this? And then once you know how to do it, then you run with it and you go. And so I am excited to be here for the rest of the day and talk to you guys about your ideas, any challenges you've had, any goals you've had. I know that Wes would love to talk to you as well, just to get you guys going, because I think it's an exciting space. We're really excited to be part of it, especially I am very excited for more experimentation with Core ML3 and understanding how that works. And here is all of my contact info and that QR code again if you want it. And I am done, and I think we have a few minutes for questions. So if any of you have any questions about any of this, I would be glad to take them. That's it. Yeah.
You said you get the information from the app in a JSON format, or you get it in a different format?
That's a great question. So we scrape it in the Python code, and then we save it as a JSON file.
Scarfos doesn't just give you a JSON. You're saying that's the difficulty of it?
Yeah, they didn't. They don't have a publicly available API. So we had to scrape the data off the website, and then we built the JSON in that Python code that I showed you. Yeah. Yep.
You mentioned being able to update models without having to resubmit. So I'm wondering if you could tell me more about what you mean by that. Data, improve the model over time.
Oh, so that's a great question. So yeah, oh, thank you. Yeah, so the question was that we talked about resubmitting or updating models without resubmitting to the App Store. And he asked, could I talk about what that means? Is the model improving over time, updating the data, et cetera? That's a great question. So in this particular case, the new model means that we have gotten the updated data from Zappos. So when they update to go from 4,700 boots to 5,000 boots, we re-pull all of that data from the website and retrain the model with this new set of data. Now, in terms of the model getting better, this one's a little bit tricky because this particular type of model is unsupervised, which means there's not a right or a wrong answer. It's not like I'm trying to predict, are these boots versus is this a water bottle, right? There's like a right or a wrong answer. With this, it's just we're presenting with choices, and if you buy any of the choices, that's sort of a win for Zappos. We presented you with something that you liked. So in this case, updating the model just means we have new boots on Zappos, we pull all that data down, we retrain the image similarity model, and then we send off the core ML artifact. So for a different use case, it would be different, but for this particular use case, that's what it means.
So one of the big things you're saying about how getting data is the hardest part. When you were getting training data, did you find that you had to normalize it before sending it to Turi Create, or did Turi Create automatically handle that for you?
So that's one of the nice things about Turi Create is it will tell you when you load the images into the S-frame, if it's the wrong like RGB format or something like that, it will tell you. But that's one of the nice things about Turi Create is we didn't have to do a lot of normalization of the images, but depending on which tools you use, you might have to do that. So. Yeah, it's a great question.
This is all just like image recognition. I mean, what if you wanted to do something like look into the patterns of like if my app has like something that would just sell stuff and it's not like visually like
yeah.
Building. I mean, the training of that you would have to. I mean, how does that work? I can't just. It's not a model of like images that I feed. How does that work?
Yeah. So you would need. So the model training code would look different, but it would be a similar process. You would maybe get data. Might be database data, maybe you'd pull it from a database. Depending on how your app worked, you may or may not have the user sending data back, but then you would use some type of machine learning library and Python to build that model. And then the model artifact, even if it's not core ML, you can still integrate it into your app. It's just more difficult. Like we talked about an example with core ML, but you can 100% do this with any model type.
Just a response to your question, we looked into this. Core ML is really only suited for image recognition and natural language processing and gameplay. It's not well suited for, say, user behavior in an app or database recognition. So you would need a different Core ML model builder for that.
Yeah, or you could use, so TensorFlow is one of the libraries. That's a great point. Thank you for that. TensorFlow is it's an open source Python library from Google, and they have a format called TensorFlow Lite, which we have some examples in a different GitHub repository about how to integrate that into your apps. So if you wanted to start building something that was not image and maybe not optimized for core ML, TensorFlow Lite might be a good place. TensorFlow Lite might be a good place to start. Yeah.
And we also had a proof of concept we're working with friendly company of ours that they didn't even use core ML at all. And we're more than open to experimenting with those things and stuff like that. We worked very hard with them. They were using DLib because, OpenCV, because at the time Vision wasn't giving enough points in the face. So they wanted to get really intricate with the face, like really pronounced. And so we worked really hard with them in order to allow the app to still be able to update those models on the fly or in real time or, ad hoc. And because they're training their models, they were submitting to the App Store almost 2 to 3 times a week. And we cut that out. But we are open, startup mentality too, is we are open to sitting down with people and proof of concept on things that's outside of the realm of just using core ML.
Yeah. Yep.
So just to be clear, the Scarfos platform, is it just the platform that is pushing the updated models, or do you actually have like models on here that people like can use and integrate? Like what is the actual?
So it's the platform, it's the infrastructure to make it easier for you to use your models. So we do have some example models, the Boot Finder model and some other example apps, but we're not in the business of we build your models for you and then you take them and use it. Like we'll definitely continue to build out examples, but part of the reason we don't do that is because when you get down to it, a lot of business use cases require, if Zappos was going to build this, they would need Zappos data. Or if, Capital One wanted to build an app, Capital One has an app, right? But that's based on Capital One data. And so these off-the-shelf models, which can be really, really useful for prototyping and getting started, for a lot of applications that you might want to use, you need to customize it. So, but I think, to Wes's point, because we are a startup and we help people to get to that point themselves.
We're not like, so you already have Google, Amazon, Microsoft Azure,
Yeah.
Watson, all those guys that have thrown billions of dollars into hardware infrastructure to GPUs, CPUs to run these things at a high, super crazy level. So instead of reinventing that wheel, we augmented it to make it easier. So it's more like really clever CI for machine learning and CD as well, because we integrate, we deliver. And we also have some really nice checks in there to make sure that like the model that your data scientist or you or whoever pushed, if there's an error, our framework will also go, no. Like we don't want your app to break because you're not going to the app store. So as much as we all kind of get turned on the head a little bit for the app store not liking it, at the same time, it does some really nice things to make sure that our app's not crashing in certain environments. So we wanted to make sure that we also gave that same kind of confidence to it. So the framework doesn't just download it and say, good luck, buddy. Like it actually runs through some background process. It's all background driven. We actually had to wait. iOS 11 came out and we took full advantage of some of the new background tasks and stuff that it was doing. And if your app's running and you allow the background to run, it'll download it when the app's not even up. So we do the right things to making sure that we take those steps. So it's like I said, it's almost like on device, really polite integration and a delivery service. We didn't want to get in the way of the $1 billion guys who are doing this. Who knows? Apple will probably share on it.
Yeah. Yeah. Yep. We have time for one more question in the balcony.
So I guess from a different perspective, are there any scenarios you guys have found where it's more advantageous to run machine learning server side instead of on the device itself?
That's a great question. So the question was, are there scenarios where it's more advantageous to run the model on the server side than on the device itself? 100%. Like there's definitely use cases, particularly so until recently, that was actually the sort of dominant paradigm because the models were just too big to run effectively on the phone. So one is, a recommendation engine. It would often be, I send my order and what comes back as a recommendation. I hit an API. So yes, 100%, that is sometimes the right architecture even still now. I think being on the phone, in addition to the privacy considerations, like if you don't have network access, you can't hit an API. Also, anything that relies on video, it's better to have it live on the phone because the lag time, even if your internet's really good, there's still gonna be a delay if you have to stream the video right through an API. So that's a great question, and yes, there are some times where it absolutely makes sense to do that. But lately we've been very focused on device, and so far we've been able to make it work. So. Well, thank you guys all so much. These were awesome questions, and I think I'm going to turn off this mic, and it's time for the next speaker. So thank you again.